Hey guys, it's Mr. Bison, and in today's video I will be taking you through the best ways of using your Casio fx-CG100 graphics calculator for A-level maths. Now I should start off by saying that Casio have very kindly sponsored this video, but everything that I'm doing here is all of my own work and all of my own thoughts. So it's worth just thinking, right? This is the calculator that most people will be using. If you have got the CG100, I think you're going to find it really, really easy to use. And if you're watching this video, you probably do have the CG100. Anyway, let's dive straight in. What I'm going to do in this video is I'm going to talk you through loads of the features, not 100% of the features because there's so much this calculator can do, that I think will support you with your studying and with your assessments and exams for A-level maths. I'll be doing a different one on further maths in the future as well. I'm going to start off though by taking you through some tasks. If you want to, you can try these tasks yourself. This calculator is very pick up and play. I think you will pretty much be able to figure out how to do most of these things yourself. Or if you want, you can grab your calculator and watch this video alongside and follow all of the steps that I'm taking. And hopefully by the end of this, you'll be in a position to be able to do lots and lots of amazing maths with this calculator. So we're going to begin by looking at some of these tasks, the graph and table mode tasks, which is in number 5 here, because it's a graphics calculator. I thought we should really start with the graphing. And we are going to begin by sketching this graph, indicating the coordinates of any intersections with the coordinate axes, as well as the coordinates of the vertex. Now, if you're watching this before you've learned absolutely all of the content, don't worry too much about it. You'll come across this later on when you're studying. So you can either scroll to number 5, or you can literally just hit number 5, and it takes us there straight away. So I'm going to try and sketch this particular graph. Now, in order to do this, I'm going to begin just typing in. So I'm going to do the 3, and then these modulus lines that we've got here, they actually come up as not something that's a standard button on the calculator. So we're going to press the catalog button, which kind of makes sense. It's going to take us through to the full catalog for things that are available. And this is actually something that comes up under number 4 for numeric calculation. And this modulus sign is sometimes called the absolute value that we've got. So I'm going to go down to number 3, which is the absolute value. We've got those lines, and I will type in 2 minus x. Now the x you should use for the variable is the one that is underneath the green shift button up there. I'll scroll to the side of it. I'll press +3, and then what I'm going to do is press OK for this, or execute. I'm going to scroll down to this part, which is to draw the graph. I'm going to leave it on the preset windows. If you want to, you can scroll down and change the x-axis and the y-axis, but I'm just going to go with this preset window, and I'm going to draw the graph. You can see a tiny little bit of it at the top. If you want to find out where it is, you can just press the up arrow, and it will begin kind of scrolling around. If you press the minus button, it will zoom out. If you press the plus button, it will zoom in. So it's kind of really makes sense the way that this calculator is designed to help you find the things that you're looking for. So the sketch is really just some kind of V shape like this. What we're going to do though is we need to find out the intersection with the axis and the coordinate of this vertex that we've got here. Well, it's very easy to see the coordinate of the intercept. It's this 9 that we have here. You can see that, but I'm going to show you how you can guarantee it is definitely a 9. If we press tools and we go down to number 2, which is graph solve, it's going to be the most popular thing we use in this section. If you scroll down far enough, you will see the y-intercept. I'll hit OK, and it does tell me that that is definitely 9. Now the vertex is the minimum part of this graph. So if I hit the back key underneath home, and I go back to tools, I go to number 2 for graph solve, and I'm going to hit number 3 for minimum value. It immediately tells me that that vertex's coordinate is 2, 3. You can see it written along the bottom of that white screen that we have there. Question 2 tells us to solve this equation being equal to 2x. So I'm going to jump back to the part where I type in the equations, and this time I'm going to add in another one, which is going to be 2x. So I shall press 2x. You'll see it's now got red next to it, meaning it's going to come up in red. I will hit execute. If you want to, you could press the tab button, which takes you through to the graph. If I press OK, it will draw it as it was before. And you can see that those lines are crossing in 2 places there. And we know that when 2 equations are equal, it's where those graphs cross each other. Now, of course, I should say, you cannot get the marks just for using the calculator. You need to show the algebra of how to do this, but this calculator is perfect for checking your answers. So we're going to pretend we've done all the algebra. We're just checking the answer. I'll go to tools. I will press number 2 for graph solve, and I will press number 4 for intersection, because we've got 2 graphs that are intersecting. One of the intersection points is when x is equal to 1.8. We can just press the arrow key and it will take us to the next one. The other intersection point is when x is equal to 3. Sometimes they ask you to sketch curves like this, y equals k over x squared, and it says that k is a positive number. Well, we can't type in k, but what we can do is we can use just any positive number instead of k. Let's tidy this up. Let's press AC to clear everything. And instead of typing k over x squared, I'm going to type 1 over x squared. So I should press 1, the fraction button, which is underneath alpha, the x button, and the squared button. I'll press execute. I can do the tab to go to the graph. I shall draw this. If you want, you can zoom out to get a bit of an idea of what's going on. Okay. This looks like this kind of graph, really. It's now we need the information to draw the sketch. It's always above the axis. It goes along like this, and then it shoots up. And it goes along like this, and it shoots down. Terrible sketches, but just to show you that you can try and, think of getting ideas of the shapes if you just put in a different value for k. Now, people really like this. You can use this calculator to sketch the curve with parametric equations. Now, if I jump back here, at the moment, it's only got a y equals. Let's clear everything. Have you noticed it does say type at the top? So if I scroll up a little bit higher, I've highlighted that part now in black. If I press OK, it gives me the option to change the type of graph. When I press OK here and I scroll down to number 3, I can do parametric. So now I can type in the x part and the y part. For the x part, I will type in sine t. Well, that x button, as well as doing x, it will do theta, it will do t, it will do whatever variable it is that's going on in the question. So I have sine t for the x part, and I have 2 cos 2t for the y part. If I don't close the brackets and I press execute, it'll do that for you anyway. Now, it does say that the domain is between 0 and 2 pi, and I'll show you where this comes up when I try and actually draw this. Let me just quickly press back. I didn't mean to press that. So I'm going to go across to graph. Now, you can change the x and y stuff, but actually if you keep going, you can change the t values. So the t minimum is 0, good. The t maximum is 2 pi. Now, 2 pi actually is 6.28, but I'll show you this by typing in 2, shift, and then number 7 to get pi. And when I do that, it has come up with that t maximum. So I can press back, not press back, I can just go straight to draw a graph. I've changed the t value, and it will draw it like this. And if I zoom in a little bit, you can see it's sort of like a parabola type thing, like this. It hasn't asked for me to do anything to do with the intersections, but you know that if you wanted to, you could figure out what those other points were. You can clearly see that this is a 2, and if you actually needed to, you can see this is -1, -2, and 1, -2 as well. It says the coordinate p is where t equals pi over 3. Verify that pi is this number that we've got here. So this is another little feature I wanted to show off. If I press tools and then number 3, it allows you to trace along the graph, and it tells you the x value, the y value, and the t value. Well, I want to see exactly where t is pi over 3. So I'm going to press shift pi over 3. Just to shift to be able to get pi, by the way, not because you need to press shift to do this. And then you can input, it says t colon, you can input the value of t. So if I press execute, it will take me to exactly that point, and the calculator is showing that it is 0.86602 for the x value, and that for the -1 value for the y. Now, they're obviously the same on your calculator. I could show it to you on here, but I want to stick on graph mode. We can see that √3/2, if you check it, is exactly that thing that we've got here. So we verified that when t is pi over 3, that is the coordinate. Okay, sticking in graph mode that we've got here, we can actually use this to draw a table of values for something. So I'm going to delete everything, clear everything, go up to the type of graph, because I no longer want it to be parametric. I just want it to be y equals. I'll scroll down to typing it in, and I'm going to be doing 2 tan x, 2 tan x, close the bracket. Now here I could go to display table like this, but it's not necessarily got the values that I was looking for. So instead what I'm going to do is I'm going to go right to the top part where it says viewing setup. I will hit OK, and I will press number 3 to set the table domain. I want it to be a range of things. So I'm going to decide what my start value, which is 0, is going to be. My end value is going to be pi. And the step is what it's going up in, which is pi over 4. So it starts at 0, press execute. It ends at pi, and it's going up in pi over 4. So it's pi over 4. Now I've got the table domain set exactly how I want it. If I press back, I can scroll down. I don't need to see the graph, and I can just display the table. So when x is 0, y is 0. When x is pi over 4, y is 2. When x is pi over 2, there is an error because when you do the tan of pi over 2, you get something that is undefined. You know that the tan of 90 or the tan of pi over 2 is undefined. And here we get a minus 2, and then for the last part, if I scroll down, we get a 0. Okay, we're now going to have a look at a different curve, a quartic curve. We're going to decide if the turning points where x is minus a half and x is 1 is a maximum or a minimum point, and then we're going to find the coordinate of the third turning point. So we're sticking in graph mode here. I'm going to clear everything that we've got, and I'm going to begin by typing in, I have a half x to the 4, so a half, scroll to the side, x to the power of is below the down button, and that's the power of 4. Make sure you scroll out of that so you don't keep typing in the power. We're then going to do minus 7/3 x cubed, like this. Make sure you come out of the power, plus x squared, plus 3x. Okay, I'm going to draw this graph. If you want to, you can change the domain. Should we do that? Should we do the preset window? We'll go with the initialized one, and we'll draw the graph. Doesn't quite show everything, so I'm going to press the zoom out button. And we can either identify now pretty clearly that when x is minus a half, that's a minimum. When x is 1, that's probably the maximum, and we'll find the other point, but I'm going to show you how we do this as well. So I'll go to Tools, I'll go to 2, which is Graph Solve, and I'm going to be looking for either the maximum or the minimum value. I'll start off with, say, this maximum value, and that's when x is equal to 1. You can see that written at the bottom here. So x equals 1 is a maximum. Let's go to Tools, back, then Tools, Graph Solve. We're going to look at the minimum. When x is equal to minus 0.5, it is a minimum. And the last one is to find the coordinate of the third turning point. You can see there's another turning point there. So if I press the right arrow, it will scroll across to it. So the coordinate of the third turning point is when x is 3 and when y is minus 4.5. It didn't ask for this, but I can also say that this is a minimum. Now, of course, I'm going to say this multiple times in this video. You can't use this to answer your questions for you, but you can use it as a fantastic way of checking if what you've done is correct. Now, I've already got this graph, this y graph sort of drawn. I'm just going to integrate this or find the area between 0 and 1. You probably spotted this, but in Tools, in Graph Solve, if I go down to number 5, I can do some integration. You can explore these other ones with root, intersection, and mixed. I'm going to be doing number 1 where you can just put the limits in. All you need to do is type in your lower limit. So I shall press 0 and it says lower bound. If you type in your upper bound or your upper limit, I will press 1 and execute. And it even shades in really nicely that little bit of area that we've got there. And it tells us that this is equal to 1.35 as written in the bottom left-hand corner. People really like to use graphics calculators to help with things like finding the range of functions. So I thought this would be a nice thing for me to demonstrate. I shall clear all of this, and I'm going to be typing in 2 sine x minus 3. 2 sine x. Make sure you close off the bracket because the minus 3 is happening afterwards. And I'm going to go and draw the graph. Okay, if you scroll down, you can kind of get a bit of an idea of what this is looking like. And if I zoom in, so it looks like we're only going to be looking at the domain of x between 0 and pi. So I'm going to probably do this by using the trace part. So when x is 0, y is minus 3. That looks like it's the lowest it can be at that beginning point. What happens when x is pi? So if I press pi, it will tell me when x is pi. Oh, it's over there. So I'm only looking at that first little bump of this graph. Looks like the lowest thing it can be is minus 3, and the highest thing it can be is minus 1. I'm going to confirm that it's a minus 1 as that highest thing by going to Graph Solve and going for maximum value. Yeah, the highest thing it can be is when y is minus 1. So for the range of this graph, it looks like the f of x is between minus 3 and minus 1. Okay, that's everything I wanted to show you with the graph mode. You're probably going to find more features, so do play around with it, particularly that kind of graph solve stuff that we've got. I'm now going to go to equation mode to answer these couple of questions. So I'm going to hit the home button and I'm going to scroll down to equation. So this one is a pair of simultaneous equations. You can either press OK or you can press the tab button to take you through. There are 2 unknowns for this one. I'll go tab through to the next part. So the coefficient for x is 3. For y, it's minus 2, and that's equal to 4. Keeps going through. We have the 2, the 1, and the 11. Press execute, or you can press the tab button for the result, and we get that x is 26 over 7, and y is 25 over 7. If you want that in decimal form, you can hit that format key, and it will take you to a decimal form for this. Okay, I am going to, either you can do the tab button to go back through. I'm now going to do a cubic equation because the highest power is a cubic. Ours is in a cubed, theirs is going to be in x. It doesn't matter, we can just pretend that x and a are the same thing. So I'm going to scroll down to this one for it to be cubed, and I'm going to say the coefficient of the cubed part is a 1, then a -5 for the squared, a -5 for the a part, and 0 for the constant, and it's also equal to 0, so I can press execute. So my solutions for this is that a is equal to 5 plus 3 root 5 over 2. If you want it as a decimal, you can press that format key. The other solution is that a is equal to 0. And the last solution is that a is equal to 5 minus 3 root 5 over 2. And of course, you can press that format key if you need to. Okay, we're going to jump out of that equation mode. We're going to go to number 1 for calculate. Now, I've said this again in the video. You are not going to use this calculator to do the work for you, but you are going to use it to verify or check your answer. So we're going to pretend we did all the maths and we got the answer 26 over 3. Quite an easy question. And we're going to see if we did get it right. So this doesn't have an integration button. We're going to go to catalog. And function analysis is going to be one of the most popular ones that you use here. And you can see that number 3 is integration. I will type in, again using the variable button, x squared, and then I'm going to say that the lower limit is 1, I'm using the scroll button to get there, and the upper limit is 3. I'll hit execute, and we do get 26 over 3, so we've definitely done that correct. Again, we're going to do something to do with first derivatives and substituting in x equals 3 to the first derivative of this. Well, the derivative is 2x. When you sub in 3, 2 times 3 is 6. I know it's correct, but let's just prove it with the catalog function and function analysis. The first derivative of x squared evaluated when x is equal to 3. I'll hit execute, and we do get 6 for this. You can also verify sigma notation stuff to do with sequences and series. You know where to go: catalog, function analysis, number 4 for the summation. And I'm not going to type it with 2r plus 3. I'm going to do it with 2x plus 3. Anywhere there's an r, I'll use an x. And then I will scroll so that I can type in here that from x equals 1 all the way up to 10. Let's hope we get 140, and we did. Okay, question 4 is to kind of show you about a way that you can do some really neat substitution that you've got here. Of course, you could just type all of the values directly, but I want to show you how you can store a value in the calculator and it will remember what those values are. So I'm going to press 1, and then underneath the shift button, the X button, is if I press shift and then the X button, I get that arrow to the right. This is going to take 1, and it's going to store it somewhere in the calculator. I want to store it as the letter A. So the first time in this video, I'm going to use the alpha key, and then I will press that X button to get that orange A. It then stores it inside A, and I can press execute. What I'm now going to do is I'm going to put -2, and I'm going to store that in B. So I should store that. If I press this button, whoops, shift, then this button, I'll press alpha and then B, so it gets stored in there. And then C is 3. So I'm going to say that 3 is going to get stored in C. Now this is going to work. If I wanted to say do B times C, I can press alpha and then get B, alpha and then get C. B times C is -6, -2 times 3 is -6. So what I'm going to do now is just type this part in. So alpha A, brackets, B plus C, close the brackets, plus AB minus AC, and we get the answer -4. So this is really, really useful if you're doing a lot of substitution. Storing values is a great way of doing this. Now, this is really cool here. We're going to do some bits where we can solve a trig equation. Again, you have to show your full method, but to check your answer at the end, this is fantastic. So I'll go to catalog. And again, it is going to be in function analysis. And it's number 5 here to solve the equation, solve n. Now, in order to do this, what you do is you will start off, you type in the equation entirely. You then say the variable that you're solving it for. Then you do the lower, and then you do the upper. You close off the brackets, and you'll ask for the answers. So I am going to check that this is the equation. It's sine of 2x minus 3 equals 0.5. So sine of, it's already opened up the brackets. That's going to be 2x minus 3. And it says it's equal to 0.5. Now, it's quite hard to see where the equals is, but it's 2 buttons underneath the catalog. It's with the K, it's the bracket, and I'm going to press shift to get to it. So if I press shift and then the left bracket, I get the equals sign. I'll type in 0.5. So I've done this first part. I then need to do comma, the variable that I'm looking for. The comma is 2 buttons underneath shift. the variable is x. I'll do a comma to get the lower bound. Oh, it's minus 180 degrees. I don't know if I'm in degrees mode, so I can change that in a second. Comma, and then the upper bound is 180. Close off the bracket. Now, before I press execute, I'm going to make sure that the calculator is in degrees mode. You can see at the top, it's in radians mode. It says rad underneath Casio at the top. So I'm going to hit the settings button. I'm going to press OK on angle, and I'm going to change it to degree. You can see it's changed to degree at the top of the calculator now. If I press execute, it does say more solutions may exist, but this is a fantastic way of checking your answers. It gives me all of those 4 solutions. If I press the format button, I want them as decimals. So my solutions for this is going to be that x is minus 163.5 degrees, minus 103.5 degrees, 16.5 degrees, and if I want to, I'm going to keep scrolling through this, and 76.5 degrees. Now, this will also work if we're wanting to do this as... what am I saying? I might clear this because it's getting a little bit busy, okay? Let's clear the whole screen. I'm also going to now do this for cos 2x as radians, and it can give you exact answers in radians here. So I'm going to jump back to radians, settings, angles, radians, and I think that's good to go. I'm going to go back to in catalog, function analysis, number 5 for solve n, and it will be cos 2x, close brackets, equals, which is the bracket button, 0.5, comma for the variable, comma for the lower bound, comma for the upper bound. And I can hit equals, more solutions may exist, and we get that the solutions for this are that x is equal to pi over 6, or a sixth pi, and 5/6 pi. 5/6 pi. And then last thing I wanted to show you is how to calculate the choose function that you might be needing for when you're doing like binomial expansion and things to do with probabilities. So to do this, you will go to the catalog. This is in the probability section. It's in number 3. The choose function, that's C. You sometimes see this written as 5 choose 3. So it's going to be number 3, which says combination, and we get that C. Now, for some reason, it's got list answer at the beginning. So let me just do that one more time. I'm going to hit catalog, probability, number 3, which is combination, and I want the 5 to be before it. I want the 3 to be afterwards. I'm expecting the number 10, I think, and we do get the number 10 for this. So 5 choose 3 is equal to 10. You'll know this when you get to the binomial expansion topic of what that means. Okay, we will finish this rather long video off of doing the distribution and statistics mode tasks. We're going to start off looking at the binomial distribution and then the normal distribution. And I love this distribution mode that we've got here. So it's number 3 for distribution. We are obviously looking at a binomial distribution, so I'm going to hit OK. And we want the data to say variable, and we're going to be calculating these different probabilities. My first one is that x is less than or equal to 10. You can see for the tail part, when you press OK here, it should give you different ones to select from. I want this first one to be that x is less than or equal to 10, so I'm going to leave it on that. The value that I want it to be less than is 10, so I shall type that in the place of x. This is the x value. The number of trials, you should know, is this 40 that we've got here. And the p is the probability, which is 0.2. If you want to, you can change the color, but it's not really necessary. So I'm going to hit the tab button to go to the results. And we can see that the answer to this is that probability that's written over here. So the probability is 0.839 to 3 significant figures. And you get this really nice visualization of what all of the different outcomes were and how common that they are. So you can see 5, 6, 7, about 7 or 8. I think 8 looks like the highest peak that we've got there. 8 is going to be the most common one that we would expect, and it kind of trails off as we go to the right. Now this one, I'm going to be doing that x is between 3 and 7. In fact, it actually says that it's greater than 3. And it says that it's less than or equal to 7. Well, the calculator is always going to be doing this with or equal to signs. So greater than 3 means that it is greater than or equal to 4 and less than or equal to 7. So I'm going to be putting the lower bound is 4 and the upper bound is 7 for this. So I'll go back up to the tail section that we've got, and I'm going to change this so that it's the in-between one, which is the second. We could have just calculated what we just did, by the way. We could have said the lower was 0 and the upper was 10, and it still would have given us the same answer. So it's going to be between 4 and 7. Everything else stays the same. So I can hit execute and then results. store that, and then go to results. And now you can see it's only shaded in the 4, the 5, the 6, and the 7 as those blue bars that we've got. Everything else is shaded out because those are not included in the probability. And to 3 significant figures, this is 0.409 probability. We're now going to say the probability that x is equal to 4. Now I'm going to show you the way that I would do this. I would literally say that the lower was 4 and the upper was 4, and it will literally just give me that one single bar. When I go to results, it gives me that tiny little short bar for this part, that x equals 4, which is 0.0475 to 3 significant figures. You can see one bar was shaded. However, if you want to, you can change it so that the tail is actually just the equal to one, which is number 4. So we would say that the x value is 4, and you do end up with that same thing of that probability at the top, 0.0475 to 3 significant figures. The last one says greater than or equal to 6, and this is where I really like the graphics calculator, because if we want to do greater than or equal to 6, I will switch it to the greater than or equal to sign, and I can change it so that the greater than or equal to 6 is here, and I can go straight to the results, and you can see all of those values 6 or greater have all been shaded in blue. This is 0.839 to 3 significant figures. Okay, we are nearly there. We're now going to have a look at something with the normal distribution, and we'll do very similar kinds of stuff with probability calculations. So for the normal distribution, I am going to be doing, here it says that y is less than 115. They do it with less than or equal to. For normal distribution, it does not matter, whereas in binomial distribution, it does matter. So we can just say, we just want less than here. Okay, so I'm happy with that first part. I'm going to leave the display z off. The x value is this value, which is 115. Mu in this case is 120. And sigma, this is sigma squared, so sigma is just the 5 that we have. You can change the color if you want to, but I'm going to go straight to the results. You get that normal distribution curve, and we can see the part that has been shaded is 115 or less. And to 3 significant figures, this is 0.159 to 3 significant figures. Now I'm going to say that y is greater than 130. So we can change this so that instead of it being less than or equal to, we can change it to greater than, because we're saying this is y is greater than 130. So it's this third option that we've got. And I'm going to change this. So instead of it being 115 for the x value, it is greater than 130. Go to the results, and we get a very small part. You can see it kind of shaded as that top end of the tail. That is 0.0228, 0.0228 to 3 significant figures. And this is where it's great. If you want to now find out missing values, so you used to do this as like an inverse normal, we can do it all here. So the probability is that y is less than a. Let's change it so that we're on a less than kind of thing, okay? At the moment it's on a greater than. Let's go to less than, which is number 1, and just go straight back to the results. And what we can do is we can change the area so that it's 0.2. I'm going to scroll to that part, and I'm going to type in 0.2, press execute, and it gives me the value over here of what a is equal to. So in this particular question, a is 115.79. Very, very neat way of doing this. And the second one, it wants it to be with greater than b. So let's jump back. We'll change it to a greater than, which is number 3. And we will go straight back to this, go to the results. We can now change the area to 0.15. And we know that the value of b, such that the area is 0.15 when it's greater than it, is, you can see that as 125.18 that we've got there. So really neat way of doing this. All right, last thing we're going to do for this is finding the mean and standard deviation from a table. So we'll come out of distribution mode and we'll go to statistics mode, which is number 2. I'm going to just start typing in this data into the table. So for the first column, I'll have 2.5, press execute, 3.5 and 4.5. Just made this data up myself. Not very exciting. And the frequencies are 8, 16 and 3. Now you'll see it says list 1 and list 2. The calculator doesn't know what list 1 is and what list 2 is. We're going to tell the calculator that list 1 is the x values or the data and list 2 is the frequency. So I'm now going to just go to setup. I'll go to the next part of this. I'm going to calculate summary statistics. That's where you will find the mean and the standard deviation. I'm then going to tell them that the one variable, the x list, is from list 1 and the frequencies aren't 1. I'm going to say the frequencies you can find in list number 2. So it now knows that this is the x parts and this is the frequencies. I'll go to execute and it tells me all the things I'm looking for. it tells me that the mean, which is x bar, is 3.3148, blah, blah, blah. And I want to find out what the standard deviation is, which is the sigma x, which is 0.6108 ... 3046 for that one, okay? And it does say n is 27. That's because all of these things here add up to 27. Okay, the last thing I'm going to do is to show you how to calculate the value of r, which is called the PMCC, for this set of data. So I'm going to jump back to the table. I'm going to clear everything for all of the lists. And I'm going to say that my x goes 13467, 13467. And then the y values that associate with this goes 2.4, 5, 6, 1, and 10. We're trying to find out like how much correlation there is between them. I'll hit the tab key to go to setup. And I don't want this to be as written like this. It's currently at one variable that we've got here. So I want to change it from one variable because I've clearly got two variables, x and y. I'm going to change it to either two variable. Actually, we're trying to find linear regression here, aren't we? So it won't work for two variable. It's going to be under linear regression. You can choose number 3 or number 4 for this. I will go with number 3. I'm going to say that the x list is list 1. The y list is list 2. The frequency is just 1. There's one of each of these things here. So we are ready to go straight to the results for this. And the thing that we want to calculate is the value of r. And they've got that the value of r is 0.4478, blah, blah, blah. And you could either do that to whatever kind of level of accuracy that was required here. So I hope that you have enjoyed having a chance to kind of play around with the CG100. I really think it is one of these kinds of calculators. You can just pick it up, play around with it, and everything should just make sense of where you're looking for things. But a couple of things I've said here might have given you a few clues to make you get a little bit faster. Do let me know if there's anything that you've discovered about the CG100 that is not included in this video. And if you do further maths, watch out because I will be doing one with further maths to give you some extra tips for some of those challenging areas of how to use your calculator as well. Thank you so much to Casio for sponsoring this video, and I hope to see you in another one of my videos sometime soon, guys. Bye.